let me, so this means देखो, this is V is equal to E minus IR. So this is V. This is V. This means at I is equal to 0, V is equal to E. So this is the EMF. Now, again, this is as far as the maths is concerned, as the subject is concerned. How do you visualize this? You visualize this, that means this is an open circuit. At this point, there is no connection. You have a battery and you don't connect it to a wire or to some so this is that point. That means this is just a simple battery. Now, this point is the opposite of it. It is short circuit. It is short circuit. What do you mean by that? You have a battery and you have connected a wire to it. No load, just a wire. R is 0 here. This is a connecting wire. No lamp. Huh? R is 0. Had there been a lamp here, that would have been a midpoint, a point here. So what does this tell us? That this point is a short circuit. And what does this mean? That means R, I, this V is 0. Why is V 0? Because V is equal to IR is equal to E minus IR. Now, if the R is 0, then this will be 0. And R is 0. So this happens at max. So you can also think of this as I is equal to I is equal to R plus R. So this value is nothing but R is 0. So this is this I value is actually this. Now, so what are we doing here? This equation is like what is this equation like? This is like y is equal to, so let us relate it to maths. Let us relate it to maths. So this is like um, y is equal to mx minus c. No, minus mx plus c. So c is e now, and this is v, y is v, and this is minus m into I plus this. Okay, we have got this. Now, how do we rearrange this? And so E minus IR is equal to V. And here we are writing E minus MI is equal to V. So this is the gradient. The gradient of this is internal resistance. Okay, this also we have come to know. Now, physically, what do you mean by this? It means that at different values of R1, R2, R3, you are going to get a different potential. That means if I change the resistor here, if I take a high resistor, I'm here. If I take a medium resistor, I'm here. If I take a low resistor, I'm here. Each time I'm getting a different potential difference and current. So basically, we are moving on this line depending on where we are, what R we are. So this is because of this factor IR. Now, is uh, we are moving this is E minus IR is equal to IR. This is constant. This is constant. This is constant. This is constant. The only thing which are varying is I and R. So that means R is deciding the V and R is also deciding I. Everything R is deciding. And the other thing you have to understand is what is happening here. Well, it's like this. If I put it superimposed it here, this is V is equal to IR. That means across the resistor, across the load. and here this is across the battery. So as this V is decreasing, this is increasing. Total energy is constant. What do you mean by that? I mean that if I have a battery, one thing you can know is the EMF. That means you look for this point, see the value, this will give you EMF. You look for this value, you got I, you got the I, you know the E. So you know R plus R. If you know R is zero here because this is short circuit. So you can get R here. So if it's like this, if in this graph, E you get it from here now, this point, this this is E. The other thing you have to observe what is actually happening. This is what is happening. Like you have a uh, you have this thing here, a resistor here, and you have a potential difference here, a voltmeter here. You are seeing the voltage of this. So as you are, this R is decide if it's zero, if R is zero here, then all the potential difference where R is zero here, R is zero here. So R is zero, and across the terminal, you are getting zero, but V is equal to IR because R is zero. So this voltmeter will read zero. But where is the energy going? The energy is going inside the R. So at this, here, all the energy is being consumed. So at this position, all the energy is being consumed by the cell. And at any other position, energy is being consumed by both, by this also and by this also. And here, there is no energy being consumed because I is zero. And V is the maximum, and EMF is. So these are the things you will come to know. You can also find the R, any R here. Supposing I want to know what R is value is this. You take the V and the I value. You can get the R value. So what you can do is V is equal to um, IR, which is equal to EMF minus IR. So if I know the V value and I value, I can get the R value, and that is how it's connecting. Then I can, if I know this value, these two values, then I can go. So you can do many things with this graph.